That's up. I'll introduce Jason Schlup, Gerald Aguayo, and Ms. Valentin. So Jason is a member of the research staff here at IDA. He is supporting DOT as part of the cyber assessment program. Jared and Misael are part of the Johns Hopkins University Applied Physics Laboratory. They are cyber professionals and software engineers supporting a large number of programs. I think I saw Virginia-class submarines, amongst many other things. So with that, I'll hand it off to you guys. Go ahead.
Perfect. Thank you. So we'll be talking today about an interesting project. We've heard some great talks about the importance of cyber testing and what that might reveal about a system. But part of doing the testing itself is collecting data about your test so that you can analyze it and figure out what the cybersecurity of a particular system is. So we'll be talking about a framework that DOT&E has been working to develop called Silence of the Logs that presents one possible solution to this data collection issue. I'd first like to start with some acknowledgments. This would not be possible by just one person. So DOT&E, through the cyber assessment program, has funded this work. And it has been a completely collaborative effort, including IDA, Johns Hopkins APL, as well as MITRE. We've had some excellent leadership both within DOT&E and at the FFRDCs and UARCs. We've got great developers that are here to help present the actual capability, as well as red team operators. There are a few in the back of the room that are helping as we work this project, and then analysts trying to figure out what to do with all this data. So, as I mentioned, tests and assessments rely on data. Without that data, you can't figure out what your system's capabilities or security or lethality really is. The problem with cyber tests, though, often is how do you instrument a cyber test so that you get useful data, okay? So I'd like to introduce a very simple example about why this is a challenge. So often when we are doing red team assessments, adversarial data collection boils down to record all activity and report on their success, right? This might be exactly what's in a T&E guidebook or in a test plan or something similar, but if this is all the guidance you are presented with, how do you do this instrumentation and data collection? So on the screen, you have your cyber operator on the right-hand side, and they're going to be doing some interaction with hardware. And let's try to record all activities and report on their success. So challenges you might encounter are protocol. What protocols are you talking with? Do you have ways to determine what those protocols are and decipher the information? If you're encrypting the information, can you break that encryption and figure out the activities that your red team are performing? Where are you sending traffic to? What time are you sending traffic to so you can do correlations with defensive data? What does it mean to have success if all you are doing is gathering PCAP, which is often what our tests boil down to when we are trying to record all attack activities. So maybe gathering packet capture information is not the solution here. Instead, what if we can just gather data at the source or at the red team operator? This data would often be clear text because the operators are typing commands into their systems. It can be interpreted by that operator or by whatever tools the operator is using. And it should be comprehensive because the red team operator is conducting these events. Therefore, at their keyboard, it should be a list of all of the activities. So it would answer the question of recording all activities. So to present an example, and I have a prize here for whoever can get this question first. It's a sticker. This is a packet capture example. Does anyone know what this packet represents? This sort of walks you through the problem of just collecting packet capture. Any ideas? Okay. I'm glad. Otherwise, I was going to be embarrassed. What if you had a little bit of help? Not the cyber operators. I'll get you a sticker later. It's fine. What if you have some help in interpreting this packet through a tool like Wireshark? Any ideas? Okay, just the one who I'm not surprised knows the answer. Okay, what if a computer through a tool like Wireshark helps you some more? Any ideas about what the highlighted box represents now? Go ahead. Exactly. So this is a ping request. You get a sticker. All right, so this is a very simple reconnaissance activity that is done in probably every cyber assessment. And if you're just collecting PCAP and relying on tools like Wireshark here to tell you what the red team operators are doing, it takes either a lot of experience or tools that can interpret that information. What if you just tell the operator to tell you what they did, record their keystrokes, and run a ping on this IP address, right? So this really is the goal for our data collection efforts. And what Silence the Logs is trying to do is facilitate the red teams in collecting that data. So this is a logging standard and a framework for capturing and processing the adversarial cyber data. We do have this lovely emoji mix icon that was generated by APL, hence the sticker. But the goal of this capability is to enable the red teams to conduct their operations as normal. So we do not want to interrupt their activities because that is antithetical to actually doing the assessment. But we want to automatically log and generate the data needed for the analysis. So that's the goal of Silence the Logs. In order to do this activity, we need a capability that is red team agnostic and technology agnostic. We don't want to develop a capability for one test squadron and another capability for an Army red team, right? We also want to make sure we're reducing the red team workloads instead of adding additional burdens to them, and specifically their data collection responsibilities, because red teams are high cost assets. They are task saturated, and they're not really data collectors. Right? So we want to facilitate their data collection, but not introduce new responsibilities for them. Any data collection should also enable reproducible analysis and capture as much activity as possible, including both successful activities as well as unsuccessful activities. So to walk through this structure, I'm going to pass it off. I think Michelle is going to start first, and Jared will have a demo for us.
All right. Hello, everyone. I'm Misal. So as Jason has been explaining, Silence the Logs is a tool that we have been developing to assist in that automating the collection and the analysis of red team data. And so Silence of the Logs, or SOTL as we call it for short, consists of three core elements. The first of these elements is the log processor, which is responsible for collecting generated log data by various red teaming tools. And so here we have an example of one such red teaming tool, so Cobalt Strike. The log processor will parse the collected log data, and it will transform it into JSON files that follow a data schema, which leads us to that second element of Silence the Logs, which is the data schema. The data schema is basically a definition of a common format that all collected red team data should follow. And our design goals with the data schema are to basically be agnostic to the choice of technologies and tools that were utilized by the red team operators in the course of their assessment. So in essence, doesn't matter what tooling, what technologies the operators use, at the end of the day, it all gets converted into a common data schema. The schema is defined in terms of entities and actions. The entities are the computing elements that the red team interacted with in some way throughout the course of the assessment. And then the actions are basically just TTPs that the red team performed against those entities. And finally, we have a visualizer, which is basically inputs the process log data and renders that into something called an action map, which is basically just a visual summary of the red team assessment. And so here we have an example of an action map. On the left-hand side, we have a legend for the different symbols that we use in our action maps, what each symbol represents. And then on the right-hand side, we have an actual example of an action map that would be generated by our tool. On the left of the action map, there is the red team domain. So this is the red team operators' network. And on the right-hand side is the target domain. And so we can see that each domain consists of a number of host machines. For each machine, we have a set of metadata that give us some information about that machine. For example, we have FQDN, fully qualified domain name. the IP addresses that are associated with those machines, the role, so workstation, for example, server, operating system. And then the last thing I want to highlight are the arrows that originate from the target domain and emanate from the red team domain towards the target domain. And the arrows are basically just a summary of how did the red team move about the system in the course of the assessment. And with that said, I'm going to hand it off to Jared, who is going to give us a short demo of the red team tool. Sorry, of the SOTL tool.
Okay, so I'm just going to kind of talk over a recorded demo for the ease of the presentation. So I'm just going to give like a general overview of like what the workflow of silence logs would be. And let's get into it. Right, so silence logs, right now the tool is packaged in this virtual machine. It's a Docker image that is ran through. So when we're going to run through the command, it's running the Docker run commands in order to run those. So when we get to, so there's a bunch of useful information on here. There's a user guide that's on the desktop, so that'll give you more information about the tool itself, like how to use it, but it also gives more information about just the tool itself, not just how to use the tool, but the different aspects of it, so we can take more of a look at that as well. So we're going to get into the first command here and what we need. So we have a input-output folder, so whenever you run any of the commands, you always need to have input-output folders to be mounted for the command. And then if we move into here, open this. Right, so this is an example of some logs that are aggregated from a red team assessment. So as Jason was saying, they would be collected on the red team's workstations. There is a CNA script that is used to just aggregate logs and just in this case Cobalt Strike. So the CNA script would be ran at the start of the assessment, and it would just be collecting logs in the background from Cobalt Strike, so it wouldn't affect any of the activities. And so all the logs are just aggregated. None of the data is changed. They're just timestamped and put into this log so that we can ingest it into silence logs for processing. So this will be, the first command will be running silence logs from end to end. So this would be taking this text file here, moving that into the data schema of the JSON, and then from there moving that into the action map. So we're going to go through the full thing. So for this first command, that text file will be the input. So since we're going to run it end to end, it takes in that text file of all the logs, and then it'll start the processing from there. So just a quick overview of the command. You have to mount the input-output folders, and then make sure to bind that text file so that it'll use that for the processing. So we're going to run this command. The output will be a JSON, which will have all the data within that data schema, and then the actual visualized action map, the draw.io file. So we're going to first take a look at the JSON. So as Misal went over, this is dummy data filled into that data schema that he was talking about. So the data is just processed into something that now silence logs can use to produce like an accurate action map based on those logs. So this is just an example of how it would look based on the data that we fed it. And then from here, this was used to make the action map now. So now we'll take a look at the action map. So the first tab of the action map will always have the icon template. So as Michelle also pointed out, it's just more descriptions about what is being presented on the actual action map tab. And the next tab will be an example action map. So the red team domain just shows the arrows to show the propagation onto other workstations during the assessment. all the metadata information. There are tags on each of the machines that give more information about what may have happened on the machine or what is happening. So, for example, a T tag in this case would be for tools, so that just gives information that the tool may have been used to execute something on that machine. There's beacon tags and exfil tags as well. So if there's still beacons on those machines, or if exfil or data was exfilled off that machine, it gives a little more insight at what may have happened on this action map. The draw IOs is useful since it's kind of flexible. You can move things around. So if any changes need to be made by red team operators, it's easy to be made. You can change information and save new versions of the draw IO file. So the action map's easy to make changes to. And then we will get into running the last command here. This one will only use the visualize portion this time. So Michelle went over how the visualize portion will take in that data schema and then make the actual action map from it. So one thing we want to point out with this is this one is using a feature called the compare to feature. So it'll take the previous logs that were outputted. So those output logs we just went over, we'll consider that our previous output. And it'll take those and compare them to a new JSON, a new data schema. So the use case for this is if usually red team assessments may span over a few days. And if you want to kind of capture a state of the day and then continue on the red team assessment the next days, you're able to compare against those and update your action map with new information from the following or the next day based on the following. So in this case, the actual JSON, which would be output from the log formatter or log processor, will go as the input. And then what we're going to compare to is what our output previously was. So yeah, so we're just changing it to make sure to use that file. And then as you can see, like on this is where the actual like command is, and the compare to flag is being used here. Once that's ran, then we get another draw.io file, another action map. The first two tabs are the same. So the first tab will be the icon template again. The second tab will be the action map that we just saw. So that's the original one. And the third tab, this one, will be the new workstations that came up in the next day during the assessment. So these are different entities or workstations from the original one. So now the operator can update their action map from the previous day with these new entities found on the following day. So and you can use any of the draw IOs for that. So like any of the previous, when you saved the changes to the draw IO, you're able to still use those and keep the changes from what you made from the previous day, if that makes sense. So now we're going to go quickly over a couple of useful features. So there's a sanitization and a word replacer. So there may be sensitive information within the logs from that network that you want to sanitize out or replace. So the sanitizer masks IPs and removes passwords, and the word replacer just replaces whatever words you want with whatever you want. So just a quick example of that would be into a file here. So if we look at this text file, there's like an LDAP dump with domain names that might be sensitive, passwords that may be sensitive. So if we run that, so if we run the sanitizer and word replacer, it moves that information into a separate text file. It doesn't lose the information, it just moves it. And then it would, you would have a new output of logs now that just has that information removed from it. Right. So that's the information we want to get rid of. When we run our tools, we're able to move that to a different text file so that this may be handled separately. And then when we look at the new sanitized file, it basically just has the whole and taken out. So that output of the LDAP that we're looking at is no longer there anymore, along with the passwords, and that's just moved to a different file. So yeah, silence of the logs doesn't really need sensitive information to make the action maps accurate, so it's not really necessary for them to be within the logs. So then if we move on to this, and then we wanted to slightly go over this. So within the user guide, as I mentioned, there's a bunch of things about the tool besides just how to use it, and including that is the JSON schema. So the JSON schemas will be constantly evolving with feedback and everything, and that will be updated as well. So it has an example of the standard we're currently using to format that data for us to make the action map. So there's a small example in here and everything that you can take a look at to see how you can format data to get the action map that you're expecting as the output, for example. And yeah, so that's the end of the demo. Jason will come back up. Thank you.
Thank you. All right, so to close out here in the last couple of minutes, I want to go over what DOT&E would do with all of this data. Just because we're collecting data doesn't necessarily mean it's useful. So what can we actually do? Particularly with the action maps, because they are a visual representation of an assessment, these are very useful to convey to senior leaders who might not know all of the beeps and squeaks to the exercise activity. Give them a general picture for what you've been doing on their network. So you can take an action map and reduce it even further by removing all the technical information and providing plain English descriptions of the activities, but you have the starting framework for your action map, the ground truth for the assessment already generated for you through the silence of the logs output. If we dive into the JSON data, because the JSON schema is capturing all of the red team activity, we can start to characterize the red team actions, what they were doing on the actual network. And a common question that is posed to test organizations or to red teams are, how realistic are you compared to real world adversaries? So we might be able to pull open source, or if you have access to not open source data about what an adversary is using, you could start mapping it. So for example, actions that an APT, an advanced persistent threat, might do are in blue on here, and the actions that the red team did, you could categorize those according to the attack framework and also highlight them. And you could say, yes, the red team is performing activities similar to a known adversary, but we're not covering the same space. Maybe we don't need to, and that's fine. But by having the data, you can now start making those observations. Similarly, you can start looking at changes over time. You might be curious about the state of cyber defenses on a particular system or a particular network over time. So by collecting all this data in a common schema, you can query it and compare previous years to the current status. And so hopefully you would see, detection trends to certain TTPs increasing over time. So by having the data, having it time-stamped, and in an easily queryable format, you can make trend observations, for example. And finally, another option would be defensive cyber operations analyses. So your cyber defenders may have certain capabilities, and so on the same sort of attack framework chart, you could say, oh, all the actions in yellow were detected during some event. So it looks like we're really good at detecting discovery activities. Great, but we don't detect any of the collection activities. That might be a problem. And so now you can start perhaps suggesting where to focus resources, where to focus training, new capabilities, or even knowing the current capabilities, why are they successful or perhaps unsuccessful? So this has been just a really short summary of the current status of Silence of the Logs. It's a continuously growing product that DOT&E would like to get to the red teams that support DOT&E, the CAP, the cyber assessment program, but also for red teams that work within the T&E community. We'd like to expand the tool coverage. Right now, the The focus has been Cobalt Strike because it's a ubiquitous cyber tool. It already has good logging functions built into it, but we know that not all red teams use Cobalt Strike. And so we will need input from the red teams and interact with the red teams to help them understand the schema so that they can develop the log processor part of Silence of the Logs to put their logs into the correct data schema. And that's really the interaction with the DoD red teams part. We'd also like to expand the visualization capabilities, refine how the action maps look, improve some of the usability of the action maps once they're generated, eventually working into the attack framework by saying this particular action in the JSON database is associated with some MITRE TTP. That would be ideal. That's a hard problem to solve, but we're going to start working on it soon, and ultimately for adoption within the OT and assessment communities. So we're happy to talk about additional operational use cases. If you have upcoming assessments, please reach out to Ozzy Perez. He's the DOT&E Action Officer that's responsible for developing Silence of the Logs. We need red team support. We need operational test agency support because this is how we're going to be able to collect good red team logs and data for the analyses. So with that, I'd be happy to answer any questions. Michelle and Jared are here to answer any questions. We're a few minutes over, so if you want to go grab lunch instead, catch us during lunch. Thank you. Yep.
Questions?
Are y'all looking at possibly incorporating this into TRMC's TINA Retina, which does the red team, blue team kind of shot validation after action assessment?
So I don't know about that particular capability. We'd have to look into what it would take to integrate with that. But we have looked at some other existing similar types of tools, like CISA had their red eye capability. And it's certainly possible. The core need for Silence of the Logs to work is the data in that JSON schema. And so there might be some instances where we have to translate from one tool's output to the expected JSON schema, but that's really how all of the tool integration with the red teams, with defenders will work. We have to create basically that log processor for all of those capabilities.
So, Chair Prerogative, last question.
Yes.
Have you guys thought about using Gen AI to get logs into that schema for things like Burp Suite or for some other, because there are tons of things in Kali you could, throw at this problem. Or looking at the JSONs themselves to, do some large statistics on that?
We have not explored Gen AI. It's possible, but of course there would have to be validation and all the required elements to make sure that it's in the right format. But it's certainly an avenue that might be worth exploring.